4.7. We're going to talk about three things here. Using the multiplication counting principle to determine the number of ways you can do something. Use factorials to count the number of permutations. And compute the number of permutations and taken k at a time. Okay, so we'll talk about these things. I think you've talked a lot about these things when you did Algebra 2, but we'll talk about them a little bit more here. Okay, so first of all, let's say we go into a restaurant and they have you order three things. You're going to order an appetizer, a main dish, and a dessert. Okay, let's say they have 3 appetizers, they have 4 main dishes, and they have 2 desserts. How many possible option of things could you get? Like, I could get a soup with a steak and a cake. That's be one combination. I can get a salad with a pork chop with a tart. Okay, so there's how many different possible outcomes of meals could I order that are different? Okay, so we're going to think about it this way. Okay, so if you write this out, we could have either an appetizer of a soup, a salad, or green salad, or a Caesar salad. Now, if I had the soup, I could have pork, steak, chicken, or salmon. I could have salad with pork, steak, chicken, or salmon, or this salad with pork, steak, chicken, or salmon. And then, if I had that and that, I could have the cake or the tart, etc. So if I could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. There's 24 different things, combinations of things that I could get. Okay. Now, instead of drawing this chart all the time, we can just think about this. How many appetizers could I get? 3. How many main dishes could I get? 4. How many different desserts? 2. So if I just multiply these together, it gives me how many possible outcomes there could be. This is the multiplication counting principle. Okay. So let's look at another example. How many license plates are in California? The standard license plate for California cars has 1 digit, followed by 3 letters. Okay, 1 digit, 3 letters, and then 3 more digits. The first digit cannot be a 0. The first and third letters cannot be an I, an O, or a Q. Okay. So if we go through, there's 26 letters in the alphabet, so we have to kind of know that. And there's 10 digits we could use, 0 to 9. Okay, now, it said the first digit cannot be a 0. So if we think about these and we write this out, there's a 1, 1, 2, 3, 1, 2, 3. Okay, so the first one can't be a 0. So it could be a 1, a 2, a 3, a 4, a 5, a 6, a 7, or 8, and a 9. So there's 9 different numbers we could use there. Okay, it says the first and third letters. So first and third letters cannot be I, O, or Q. So if there's 26 letters and we take those 3 out, there'd be 23. So 23 different letters I could have there or there. And the middle letter here, it could be any of those. So it could be any of the 26. Okay, and the last 4 are digits. It doesn't have any, so no, it could be any of the 10. So it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So there's 10 different numbers that it could be. So what you want to do is how many different possibilities, you just multiply these all together. So when you multiply these all together, it comes up to be 1, 2, 3, 7, 8, 6, 0, 0, 0. So over 123 million license plates could be made with their stipulations they have. I'm not sure, it'd be interesting to know why they can't have those letters there. But anyway. Maybe because they might think they're zeros or O's. Maybe, I don't know. Okay, so this is the idea of a permutation. So permutation helps us determine how many people or things or how many outcomes there could be. Okay, so let's say, for example, you have 5 framed photographs of different family members you want to arrange on top of your dresser. How many different ways could you arrange these? Okay, well, the first photo could be one of 5 people. Once I have one photo there, the second photo can be one of 4 people. Once I have 2 photos down, it'd be one of 3 people, and 2 and 1. If I multiply those all together, I get 120. This is called a permutation. A permutation is a distinct arrangement of some group of individuals. Okay, so we also want to think about this factorial. If you remember this, the factorial is like an exclamation mark. So if I find 5 factorial, that's the same thing as 5 times 4 times 3 times 2 times 1. 8 factorial would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And you can find this in Desmos as well, if this factorial button. Okay, so let's look at another thing here. You are the manager of a baseball team, and they've picked 9 players to start in the game. How many different ways could they be arranged in a batting order? So a batting order is 1 through 9. So batting first could be one of 9 people. Batting second, if one person's already batting, could be one of 8 people. And if there's 2 people, there's one of 6 people, 5 and 4 and 3 and 2 times 1. Now using the counting principle, you could just multiply those all together. Or you could also realize that this is 9 factorial. And then you could go to your calculator or Desmos and know that 9 factorial comes up to be 362,880 different ways they could make a batting order. Okay, now let's say I don't want to choose everyone though. So let's say there's a classroom and there's 28 students in the classroom. They put all the names in the hat and they mix them up. We're going to draw 3 names out, one at a time. The first student gets to operate the calculator display for the day. Second student's in charge of reading the answers to the even numbers. And the third writes down class notes on an interactive whiteboard for people. So there's 3 different jobs. How many different ways could I take those 28 people and give the 3 people jobs? Okay, so there's 3 jobs. I'm choosing 3 people. There could be one of 28 people that I choose for the first one. If I already chose someone, there'd be one of 27 people that I could choose for the second job, and one of 26 people for the third job. So I can multiply those 3 things together. Okay, so 28 times 27 times 26 gives you 19656. Okay, there'd be that many different ways I could choose people to fill the jobs. That would take 109 school years to go through everybody. Anyway, so let's keep going here. So I could do that. Now another way to do this is we can use this permutation idea. Okay, so I'll show you how to do this in Desmos as well in class. But there are a total of 28 people, and it's a permutation, and I'm selecting 3 people. So if I can put this in the calculator in Desmos, and it also gives me that same answer. Okay. So we can use permutations if the number of different permutations is selected from an entire group. Okay, we'll talk about combinations tomorrow. This is permutations though. Okay, so let's say we have a youth baseball team has 15 players. How many different ways are there to select 9 people to bat? Okay, well, I could do it 2 different ways. I could think, well, let's do it the hard way first. There's 9, 2, 3, 4, 5, 6, 7, 8. There's 9 people batting. If there's 15 players, one of those 15 players could be first. If I already chose one, it'd be one of 14 people next. Chose 2, be 13 people left to choose from, and 12 and 11 and 10 and 9 and 8 and 7. Okay, so you could multiply those all together. The quicker way of doing it using Desmos is there are 15 people, and I'm choosing 9 positions for them to be in. Okay, and you get your answer then. Over a billion, 1.8 billion different ways you could arrange those people in batting orders. Okay. To arrange these permutations, I will not have you work out the formula for it. I'll probably just say you can use Desmos and work it out. But this is the formula you would use. Okay. So if I want to know, if I want to do this one right here that we just did, that would be n factorial would be 15 factorial divided by n minus k. So subtract those 2. divided by 6 factorial, and this is how that works. Okay, so if I have 15 factorial would be this, and 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. So 6 over 6, 5 over 5, all those cancel, so you notice we're just left with what we wanted up there, but that's how you can figure out the permutations. Okay, so we'll do one more problem here. A local ice cream shop in town is called 21 Choices. Why? Because they offer 21 different flavors of ice cream. Dontrell likes all but 3 of the flavors that 21 offers. They don't like bubblegum, butter pecan, and pistachio. A 21 Choices basic sundae comes in 3 sizes, small, medium, or large, and includes 1 flavor of ice cream and 1 of 12 toppings. He has enough money for a small or medium basic sundae. How many different sundaes could he order that includes only flavors that he likes? Okay, so we have to choose a size, ice cream, and then a topping. Okay, those are our 3 things we're choosing, right? So it says he has enough money for a small or medium, so there's 2 different types of sizes he could afford. Ice cream, it has to be one that he likes. So there are 3 that he doesn't like. So 21 minus 3 would be 18 choices of ice cream that he could use. And the toppings, 1 of the 12 toppings. So there's 1 of the 12 toppings there he could use. Okay. 18 times 12, 432 different things that he could buy, different combinations. Okay, number 2, he could order a cone with 3 scoops of ice cream instead of a sundae. First, to have 3 different flavors variety, and considers the order of the flavor on his cone to be important. How many different 3-scoop cones with 3 different flavors that he likes are possible? Okay, so he has to like them, so how many could he choose? Okay, there's 3 scoops. Okay, the first scoop could be 1 of 18, because there are 21 choices, but he doesn't like 3 of them. And then if he wants them all to be different, the next one would be 17. And they're all different. There'd be 1 of 16 different choices. Okay, this would be the same thing as there are 18 choices. He's choosing 3 of them. And then 18 times 17 times 16, or this factorial, comes out to be 4,896 different possible cones that he could buy.